13. Okay, so 1, 3, 7, and 13. Let's see, is this a quadratic sequence? And the first rule when it comes to patterns, right? Forget about the sequence part, just talking about patterns. We need to first identify the type of pattern. So from 1 to 3, I'm adding 2. From 3 to 7, I'm adding 4. And from 7 to 13, I'm going to be adding 6. Okay, and so this here, again, that's my sequence of first differences. Right? And then I'm going to go further and I'm going to say, well, okay, between 2 and 4 I'm adding 2, and between 4 and 6 I'm adding another 2. Okay, and this here is a constant second difference. Now when I see a constant second difference, I immediately know the following is happening. The following is happening, right? I'm going to say this is a quadratic sequence. Why? Because there's a constant second difference. Now, the way to determine the formula for this is to take that, and that, and to say, well, okay, this here again is going to be 2a, that over there is going to be 3a plus b, and that over there is going to be a plus b plus c. And so let's look at this. The general formula for quadratic sequence is Tn equals an squared plus bn plus c. And now what I want to look at specifically is calculating the coefficients of n, which is a, b, and c. And what do we get? Let's start. Let's go black again. I'm going to start off with the first one and say 2a is equal to 2, and therefore a must be equal to 1. I'm going to the next one and I'm going to say, well, okay, 3a plus b is equal to 2. That's 3 multiplied by 1. The 1 comes from here. I'm going to say plus b equals 2. Now I solve that. I say b equals 2. Take that 3, subtract 3 from both sides, and I get b equals minus 1. Now I'm going to take all of these values and plug it into a plus b plus c. Okay, so let's get some red going over there. A plus b plus c is equated to 1 coming from there. Okay, and so let's take that a is 1, that b over there is going to be plus negative 1, plus c equals 1. And 1 minus 1 gives me 0, so 0 plus c equals 1, and therefore c simply equals 1. And now I'm going to take this a, b, and c, and I'm going to plug it into this thing over here, the a, the b, and the c, and that's going to give me my formula. So it's 1 minus 1 and 1. Okay, so let's see what we get. In general, we have Tn equals an squared plus bn plus c. And what does this give me? Well, it's going to give me the following. Tn equals 1n squared minus 1n plus 1. And that simplifies to 1 squared minus n plus 1. And let's substitute in values, right? T1 is going to be 1 squared minus times positive 1 plus 1. And what does that give me? 1. Okay, let's do it on this side. Minus 1 plus 1 is 0, and 1 squared is just 1, so I get 1. And you can do this on the calculator if you really need to, but I encourage you not to. Use your brain. Let's do this. Okay, let's put in 2. 2 squared minus times positive 2 plus 1 is equal to 4 minus 2, which is 2, and 2 plus 1 is 3. And let's say 3, it's going to be 3 squared minus positive 3 plus 1. And so 3 squared is 6, 6 plus 1 is 7. And if we do it for the next one, you're going to see you get this sequence 1, 3, 7, and 13.